Good afternoon, ladies and gentlemen. It is afternoon, just about. We're here to talk about software, the revolution for automation and robotics. This afternoon, I've got some top-class speakers to discuss this topic with you. They'll come up onto the stage. Rainer Brehm, who's the CEO of Factory Automation at Siemens Digital Industries. Wendy Tan-White, CEO of Intrinsic, and Professor Sami Haddadin, the director of MIRMI and founder of Franke Emeke. Please have a seat. As a warming up question for everybody, we're going to talk about robotics and software. So as a warming up question, I thought, okay, I'll ask these guys, what do they really know about programming a robot? And we'll start off, we'll give the easy one to Wendy, I think. What was the first robot you ever programmed?
I was sponsored by Ford Motor Company through university, so I did computer science. And so my first summer, I had to program a Ford production line through green screens on a kind of Unimate with some industrial robotics. But in those days, it was literally green screen scripting. Yeah. So I think what we're about to talk to you about today is a step change beyond that. But yeah, that was my first programming of robotics. Yeah.
And this is a surprise question. None of them knew what they were going to be asked.
It's actually a little known fact. I started at Ford doing that, but there you go. Yeah.
So we'll come to Rainer. What was the most recent robot you've ever programmed?
Well, not in an industrial use case. My son got a DJI Robot Master for birthday, and I did some Python programming on that. So it was for private use. So I started using Python. I didn't do that before. But now I know how to program Semantic, and with a Semantic controller, you can basically program all different kinds of robots. So with programming Semantic, it's also possible.
Sami?
It's a tough one.
The most difficult question. What's the most difficult robot you've ever programmed?
Oh, that's a tough one. Okay, that's probably the gizmo robot of my daughter when she was building it, and I had to control something that was not designed to be controlled. So that's the private answer, and the most complex is actually an intelligent prosthesis we just recently developed, because the prosthesis has to forecast in real time what the human wants to do. So it's pretty tough to program something that needs to anticipate what the human is supposed to do in real time. I'm not sure we have done it yet to the extent that it works perfectly, but we're on it.
We'll delve deeper into all of these topics in a second. My name is Ken Fuhi. I'm the editor of VDI Nachrichten here in Germany. Thinking what's the most difficult robot I've ever had an interaction with was probably Alexa this morning when I had to get out of bed. But and I had to leave Dusseldorf at 5 o'clock, so it was pretty early. Okay, so coming to our topic, software and robots today. There have been a lot of parallels that have been drawn between the development in the cell phone industry and the developments in robots, looking as to what's going to come. Looking at that, do you think that the developments in the robotic application industry are on the verge of a similar development, a similar pathway to what's happened in smartphones in the last 12 years?
I could have a crack at that. I think there are 4 billion smartphones today. Yeah, if you predicted this 15 years ago, that was not the number they predicted. Yeah, so pre iOS, pre Android, nobody would have predicted there would be that many being used consumer-wise. We have 3.5 million robots today in industrial robotics. Yeah, which is not actually a lot if you think about it. Yeah, at the moment it's predicted by 2030 there'll be 10 million. I actually think it's going to be beyond that, and why? Because I think there'll be a step change in the market and ability to build solutions using robotics that will lift the whole market, and there'll be more robots, ROEMs, more robots sold in that next period. And I think we'll move to SME, not just to traditional industrial, and I think from there we'll also move to consumer. And why? because people need solutions now using robotics and automation in a way they didn't pre-COVID, in a way they didn't pre-changes in geopolitics, and in the way we need it because of sustainability and reshoring. Yeah? And that's why the market's about to step change. And I'm making a bet on that. I'm a software person coming into robotics, because in over 30 years I've seen this cycle happen a couple of times, and I think the time for robotics and AI is now, actually.
Rainer?
Yeah, maybe, I mean, what the iPhone basically, why it exploded, because it's easy to use. Number one, and number two, it built an ecosystem around developers which added a functionality to that ecosystem of iPhones or Android phones. And I think there are similar development in robotics side. So we need to make it as easy as used as possible, because currently the limitation is not the number of robots which can be built. The limitation is how many people are capable to program a robot. So if we can make that easier, and what we do, for example, we're using semantic TAA. We have 200,000 users every week which can program semantic. That's already, and they can program robots in the future. So that's already one big step. But we need to be even easier. We need to work on leveraging new technologies like AI to make the programming of robots as easy as possible, using simulation, using digital twin, number one. Number two, getting ecosystems, so getting people attracted to work in this space. And currently the world loves IT, yeah, but it runs on OT. So how can we make a lot of people in the IT world being attractive to do OT workload and to benefit for benefit of industry?
I think in these two statements we've covered the whole of what we're going to talk about in the next 40 minutes. But Sami, how big could this market be?
Well, I mean, in a way, I think...
You've heard a number.
Yeah, the numbers. I'm not the numbers person. I'm a scientist in the end, right? So in my imagination, it's huge, which means billions of robots at some point in the world. I could argue that we already have a lot of robots in the world, right? I mean, we not only have industrial robotics, we have some personal robotics. We have more and more robots in, for example, in logistics, enormously growing since the pandemics. We had robots on Mars. We have robots in the OR. We have more and more robot cars, right? So I think this is the numbers that are steadily growing. But I think what is most important, because we talk a lot about democratization of technologies. So when we introduced for the first time robots that can be programmed by apps and visual apps, that was kind of considered quite a breakthrough. Why? Because a very complex technology could be made useful to the user. But I think first comes the function, and then comes the form of interaction. So I think what we need to make sure is that the technology we're developing has use for humans, because no one, at least in the regular world, will pay for a robot that has no use. And only then comes the usage in terms of UX and UI and making it accessible. So I think it's really important that we put the functionality at the front. So is it mobility? Is it some manufacturing steps? Is it support in healthcare? You know, what exactly can they do? Like a trained person, right? And then the question that arises very quickly is who can program them and who can use them? So then comes this usability, user experience into account. And I think we will not just see a step in robotics and then, you know, the robots will be everywhere. I think it's really more and more specialized systems that are pretty broad in what they can do compared to 80s, 90s industrial manufacturing robots, but still very, very niche systems in capabilities compared to what we humans can do. And as a last point, maybe just to make this very clear, smartphones were originally telephones, right? So we were communicating. That was working already, roughly, right? So we had smartphones, or telephones before smartphones. So I think, again, there, the functionality argument is very clear. So you need something that people really want, that they use, and then you can build ecosystems around it. If it's something that maybe has not the perfect use case, then maybe there is something missing. So that's a bit of a thread I can see there.
You've mentioned one of the key words, ecosystems. We'll dive deeper into that in a second. But if you look at the analogy, I'm going to stretch the analogy with smartphones a little bit. There are essentially only two ecosystems in the smartphone industry with iOS and Android. How many ecosystems, platforms are going to exist for the robotic applications?
I think the platform story and interoperability that has to happen in robotics and automation is only really expanding today. I also think this is where the parallels break down a little bit with the iPhone and Android phone, in that there is not just one device in this ecosystem. Yeah. There is not going to be like one reference design that plugs into an iOS for robotics and automation. So there needs to be a lot more interoperability actually between all the platforms in play, which is actually a good reason. For example, we actually did the partnership recently with Siemens, because we knew that on the IT side and the robotics AI side, we were strong on the interoperability, but on the OT side of more traditional PLC type devices, we weren't. And we thought actually we need to integrate that. Most people want solutions with all types of devices and the IT IoT together. That's just a good example of where we actually need to become more interoperable as an ecosystem. And there will be room for many players, I think, in that.
So at the show here, they're all users of robots, the customers. How should they view what you guys are doing here? How do they hedge their bet and say, okay, I'm going to buy Siemens or Intrinsic as my OS or as my platform for the future?
I think
How should
it's
they behave?
our job to be accessible, actually. It's our job to be easy to interface such that, and be open. Actually, I learned, I take some of this from one of my colleagues, Brian Gerke, who's over there actually, who was the founder of Open Robotics. So I think a lot of you know Ross. That is open and interoperable. Yeah. And I think there is a lot we can learn from that open source community and bring that more into a commercial, industrial setting where we can actually use that decentralized model better as an industry.
And maybe to add on, I think Intrinsic is very much focusing on a cell or on the robot application. A robot normally is integrated into a complete machine or a line. And normally this is controlled by a PLC. So the first thing coming from a customer perspective, the limitation is, can you integrate that robot into a complete automation solution? I think we can work here together. I think number one. Number two, I believe the future of automation, where is automation strong today? If you have repetitive tasks on high scale and known tasks, there you automate today. I want to automate in the future the unknown. So I want to automate something which I didn't know what to automate when I was writing or kind of implementing the system. And there you need AI, and there you need then maybe skills, and Intrinsic believes in the skill concept, we as well. And how can we maybe then combine skills, leveraging new technology in an easy way? I know it looks like the eierlegende Wollmilchsau, but you make it as easy as possible to maybe really in the future automate the unknown. I think there is a very interesting journey. And we have both said, let's explore the market, let's create customer value and where it makes sense. And maybe in the future it's an ecosystem of ecosystem. Yeah, for sure we will have an ecosystem as Siemens. We want to drive it forward. We bring the IT technology in. Intrinsic builds one, very focused on certain robotic skills, and then let's find out from a customer perspective how that creates value.
Sammy, you're going to challenge that?
Well, to be honest, I'm listening to that, and I think Ross is a great example. But I would love to understand, because we are at an industrial fair, right? So there's many people from industry,
yes.
And I'm an academician, so we share, right? That's we you say you're born a scientist or you're born an industrialist. So as a born scientist wants to share. We want to share knowledge. We want to create knowledge, and this is what Ross was, kickstarting in robotics amazingly. Especially when we remember the times in Willow Garage back then, right? When this was a beautiful community. The question is, was it sustainable in a business sense?
Yes.
So I think what is one major question that the community will have, I guess not on the science level, but on the industry level, how do they fit into this ecosystem of ecosystems, and how can this really become a model that they understand, that they can, because they're coming from a different world, right?
Yes.
Monoliths and very specialized systems. So I think this is super interesting to us as science, because we have been working like that for many years and decades, and now seeing this in industry is fantastic to see, and seeing such great players want to push that forward.
Maybe can I use a real example to try and help how I think the market will change? So for example, one of the use cases we were looking at with Siemens was in let's say a machine tending use case, and the idea was we wanted a smaller, more automated cell that maybe a smaller business could use cost effectively. And so what we looked at is, okay, how can we do, for example, a smart pick and place off a conveyor belt, put it into a CNC machine, unpack it, send it off on its way. Yeah? So what we needed was an integration of skills. To do that type of smart pick and place, we wanted a certain type of computer vision skill, some force feedback skills as well, and then combine that with some of the OT skills. But what we've done is produce a product called Intrinsic Flow State, which lets a process engineer put that whole application together. So somebody that is not a programmer necessarily or an integrator could put that together, test it in simulation, and then deploy it. Now, what does that mean? It means that people that have real problems to solve in a world where there is less and less skilled labor to do that could actually build an application very quickly and cost effectively, but also change that process themselves very quickly. And what that will do is open the market, yeah? And then if you open the market, what we'll need is, we'll need more robots, more devices. We'll need more people being able to program skills around AI to add these skills in. And so actually, it should lift the whole market. So you, as a set of players, actually have a bigger market to build into that's not proprietary as vertical, and it's not as constrained to, I think a lot of the hardware providers here provide hardware to automotive because they're the only ones that can afford to amortize that capex over like 7 years. Yeah? We actually need to change that. In some ways, the business models of this industry are actually stopping the market growing at the moment. And I think it's all to play for right now. We should actually try to break that.
But exactly what Sammy has said, there's a big barrier, a big fear of the small, medium-sized companies to jump on a platform like this. I'm sure Siemens isn't afraid of getting close to you guys, but a lot of the small people will be. And how will you overcome this fear? How will you convince them that's the way to go?
I think we will share the value of that. So when I talk about a market growing, we don't intend to take the value off the table ourselves, all of that. I think the idea is more we're enabling. So for example, in the use case I talked about, if somebody wants to add a particular skill, let's say a vision skill in, or they actually want to add their device in with the skill, we would expect to share the value of that. If per application deployed, or per robot deployed in the real world, with those providers. Yeah? So it's not going to be us that takes that value. I mean, obviously we take a small amount for the enabling and the distribution of that platform, but we actually expect the rest of the ecosystem to take the extra market value that grows from this.
And maybe to add on that, I mean, I think what we need to do, I mean, maybe economy, the sharing or open source sharing, I think industry standardize. And we need to standardize because else we will not scale. And we need to find ways of, where you put standard interfaces in, everybody can access. Data should be accessible to others because data don't lose value when you have used it. The others could use it as well. And when we talk about skills and things like that, how can we standardize? How we can standardize on a communication? How can we standardize on skills? And then basically everybody can participate because standards are there. And there is not a lock-in on certain aspects, and I think we need to drive this forward. And industry normally is good of putting standards somewhere in order to scale up.
Actually, Rainer, can I share a little bit of a story about how we first met and why I'm just going to back this up. So Rainer and I have been talking for a couple of years about doing a partnership, and actually we didn't for a while. And we didn't, can I just be blunt about it? Because some of my advisors were like, don't do a deal with Siemens. They're too big, they'll take too long, they're going to be proprietary, they're not going to be open enough, etc., etc. And so I sat down with Ryan and I said, look, here's the vision, I think, of what's going to happen with the industry shifting. And he was like, actually, no, I do believe that. And I was like, okay, but you actually have to show us, in reality, why you mean that. Like, what are you going to do? And actually, we actually came up with a real project in the end to actually... I actually said to you, look, if we can't do something, I don't care about the money right now, we can't do something where you should prove validation very quickly, well, it's not going to do it, because we're short of resource. Time is more important to us right now, and speed to market. And actually, he was like, all right, let's have a go at it. And they actually proved to us they could move quickly, and they proved they actually care about being more open, actually, which is why we've got, this is quite an unusual partnership for Siemens to do a collaboration like this, where they're actually more open. Sorry, I'm dropping you in it, but is that fair?
No, so you told me you are for sure too slow.
I did, I did.
And,
I said, you're too slow, I'm not going to do it. Yeah.
And at the end, I was happy that we're sitting in a meeting where we said, well, we have done this, what is now Intrinsic doing? Can you move? So, no, anyway.
You pushed that, it's true, actually. In fact, Boris pushed us over there. Anyway.
No, but I think what is absolutely true, we share same vision, which always helps. I mean, and then everybody will find a certain place, moving forward on that vision. And if you talk about, we want to bring IT and OT together, you can talk about it or you do it.
Yes.
And basically we say, let's do it. And maybe there are some language barriers or whatever, but you have a lot of industry experts as well already, and that helps us a little bit to interact. But we need to do it jointly, and it cannot be with the one or the others. And it's not about talking, it's about doing, and we do.
Yes, and we were grateful for that.
Maybe one thing that is kind of interesting when I listen to that is we hear a lot about industry is about standardization, right? So you just said that, Rainer, in a way that in order to create compatibility, intercompatibility, and ecosystems, I 100% agree on the standardization aspect. What is, however, interesting, if you go around, and we are slowly moving as a robotics community, there's always specialized solutions, right? That's kind of an interesting observation if you look at what you see, that in the end, the standardized components seem to be fewer, at least for someone coming from a scientific perspective, than you would foresee and would think if so much is standardized. So what are your thoughts in terms of how can we get to more standardized solutions, not only standardized components? Because there seems to be still a lot of way to go from the standardized software and mechatronics components to the actual solution, and having a solution that is, good enough for industry, but also broad enough to be deployed to many other solutions in a way, or other use cases in a way. I would love to understand your thoughts on that. Sorry for asking a question.
Yeah. Maybe I could bring AI into this, right? I think it's obviously a very current topic. Some of the breakthroughs we've had with Intrinsic was really around artificial intelligence. There's Torsten here. Torsten, our CTO there. Some of the breakthroughs we really looked at was in the area of, for example, real-time force feedback and vision. So you can see and touch and feel in real time, right? If you can do that, you can actually take a more generalized process and actually react in real time to a situation. So you don't have to be so specialized in that. And I think that's changing. And so what we've done is create a framework where we can, but also other people can add almost AI-driven skills, and we put the infrastructure underneath that to support it. So the compute, the perception, and the sensor skill base to do that, and data. And I think that's going to step change the industry as well. Much like, maybe the parallel there is even in things like ChatGPT. There's now a big race on to whether you can move towards generalized artificial intelligence. I think that parallel will move into the physical world. That's the next bastion. Can you take that learning into the physical interaction of the world? And I think we will. And I think that will create more generalized solutions.
Before we go off on the AI tangent, which we'll get to in a second, I'd like to stick with this standards development, because generally in industry, the development of standards is very, very important for the adoption. And also in all of the applications of robots in industry, functional safety is an important part. How will you develop that going forward here? Will you wait for standards to be developed, or will you essentially make de facto standards, which is the software industry's way of doing things?
I'm going to hand this to Rainer. It's one of the reasons we actually partner with Siemens, because they do really understand standards, and we're going to run with some of the standards they're looking at.
Well, waiting for safety, I think we sell 50% of our large PLCs with safety integrated. So it's not a niche or something like that. It's already kind of mainstream. And what we do also in the combination with robotic, for sure you can have a controller and you combine it with a robot and you have safety signals. There is ProfiSafe, which is a standardized protocol, and we're using that. And we're building that more and more into more functionality. But it's not at all waiting. It's, in my opinion, it's getting standard. It's not a niche.
And how will you integrate that into an ecosystem that will work with Intrinsic?
Well, there is, as you said, there are, I believe in the future you have skills or standards, whatever you're going to, and maybe on the standard one topic, I like the process industry. And with MTP, they basically said this could be very specialized, but you have a standard. OPCOA with companion spec moves into standard. Inside, it could be very specific and very dedicated, but at least you have a standard you can communicate and get right data. And I think if you then combine skills, there are functionality with safety inside, and you combine them maybe with skills which are not safety, but in the combination it's going to be safe.
We actually have architected our stacks such that we use OPC-UA. We're going to be adopting things like asset administration shell as a structure the same as Siemens already uses. That's partly why we're more interoperable already. We have a lot of industrial experts in our team, people like Torsten Kroger or Martin Hagel or Rainer Bischoff, who've actually brought in an awful lot of this idea of how do we bring safety in. Actually, Siemens, you've had some good progress in terms of getting certified around certain processes, etc. We'd actually like to sort of learn and piggyback off the back of that too. So, we're very much aware of having to fit into that ecosystem.
Well, I mean, in a way, what is great about having the two of you here is, I mean, if we go to robotics, we see a lot of this collaboration going on, right? Human robots interacting, no safety fences. I think this is also a bit where you're going. But now we have to discuss also, because of having Intrinsic here and Siemens on stage, how do we get certification, functional safety, and AI together? Because we've seen, or it seems at least, that the automobile industry has quite a tough time, and just for mobility, right? Just driving around, in a way, seems to be quite a tough problem. So I think one of the fundamental questions that we, at least in science research, we face already today, and since 10 years actually, how do we make the collaboration and the interaction of robots and humans such that they really can integrate safely in a not only industrial environment, SME, and potentially in a service robotics environment. I guess this is really where we all want to go. So in a way, I think what is really important is that to acknowledge that the pull from big players in robotics is maybe not 100% there yet. So it would be great to see you guys really pulling the robotics industry in the sense of saying, look, we want to be the ones empowering humans and machines, collaborating, coexisting, interacting in a way that is not only safe in the classical way, but in the modern way, right? In a way where they become tools, where we, it's not just we're sitting next to each other, robots and humans, and being suspicious of each other, but really being a team.
Yes.
So I think this would be fantastic to see this opportunity that's obviously here on stage, right?
Yeah, but I mean, that's a research topic, and we are doing that because we want to develop safety further. I mean, there are a lot of areas where you could apply safety, and applying safety in combination with AI is nothing easy. I think we are not there yet, but for sure we are working on ways how to do that. And as you said, automotive industry, they are maybe front runner. If you want to have an autonomous car, you're using a lot of AI. You need to be safe. So maybe we can learn also from there, and we are in discussion, how we could apply safety within AI, not only in robotics. We're using AI in different processes, engineering steps. So, but then having the safety component with that's not yet solved, but there are trackways where I think we are in a good way.
I think the vision you're talking about robots and human working really collaboratively and human trusting, actually, robots now is actually really, really important. One of the reasons is intrinsically started in industrial because it's more of a constrained environment, which actually has more understanding around safety already, and it's more structured in some ways. We didn't intend to just only support industrial. Ultimately, the data, the skills, the manipulation, the mobility, ultimately we're going to go towards will be important both in services and home as well. But we think we can learn a lot in the industrial space, and actually we might be able to drive some of the standards from there. The thing about autonomous vehicles, in a way they took the hardest problem first. There are so many edge cases in autonomous. The safety is why it's taken so long to get to the safety part there. If we start more in an industrial space, we actually have a better chance of solving some of that first, and then maybe translating some of those standards into service and consumer.
So you know what's interesting about that, because this statement has been there for many years. We should start in industry because then we can translate. Makes total sense, I think. Yeah. There's just one interesting observation in robotics that we've seen so far, because there is safety standards, right? There is human-robot collaboration safety standards, but we have the speed requirement from industry, cycle time, right? Cycle time is really what industry cares about, and cycle time is inherently what makes robots. I mean, reduced cycle time means increased speed. Therefore, the robot is intrinsically more dangerous, right? Yeah. Which is maybe not what we want in the shop floor. So I think this makes a lot of sense, but it needs also the boldness to say, look, let's take that step. Because what we have so far are extremely conservative standards that are maybe almost a decade old. In a sense, back then it was the best thing that could be done. It was a pretty broad process internationally. And I think what would now be really time is that this bold vision we hear is really taken to the next level. Because if you want to make it reality in industry, human-robot collaboration on a scale where cycle time is productive, I think this is really the envelope in which we need to move. Otherwise, there will not happen the scaling in industry because it's not productive, right? So that's kind of the competition we have there.
I will allow some questions in the end here. We've got another about 12 minutes here on the panel. I've got two further topics that I want to talk about with you, and then I'll open it up for some questions here. If I understand now the discussion that we've had up to now, it's professional users in industry are the target group. But what about and you mentioned it, Wendy, humanoid robots as everyday helpers. What has to happen for robots to become suitable for everyday use? What has to happen to be able to really trust the robot?
I think it's actually what Sami was actually just really alluding to, which is how do we bring enough standards that you can start to experiment more in a closer environment with other human beings. So I think there needs to be a way of experimenting on that to move to be honest, the algorithms and the safety standards forward to play in that space. So I'll give you an example. Even our beta is open from later this year, and one of the things we're hoping is that it won't just be limited, to be honest, to industrial form factors. Yeah, we're not form factor dependent. So whether you use a mobile robot, a static manipulator, a humanoid robot, we don't actually mind. You can build your own skills in to actually manipulate them. But we do know that we're going to need a safer sandbox to actually play with, to actually move forward service industry and a consumer. And I think actually, as bigger players, that is something we can look at, is can we create those sandboxes somehow and shift, quite frankly, whether it's government or bodies to actually let us do that. Yeah.
Well, I'm not an expert on consumer or household devices.
Yeah.
I know that we need to have the acceptance. We need to get robots which will have skills, which are trained, basically that they can automate the unknown. And we are doing that, like we have an AI app, flexible grasping, where we exactly do this. We need to develop this further. So we need to find ways of how it's very easy to integrate, or you need to, if you train it, you train really with only a few samples, because else it takes too long time, the effort is much too high. So either without training or a few samples need to be doable, and I think then it also scales more in industry.
I also think the change in, to be honest, computer vision, intelligence, and touch force feedback will make a difference in real time. So this is the thing we've designed in terms of our controller, is that you can have that real-time feedback. That will also make a difference in how well you can interact with human in real time. I think that is also going to be the step change.
I love that statement.
Good.
Obviously, right? I mean, having robots with sense of touch, I think, is really the biggest breakthrough in robotics, because they don't only want to talk, they don't only want to move, they want to do stuff. And in order to come from the age of information, where we come from smartphones, into an age of action, where robots are doing things in the real world, it's not only about observation by seeing and maybe communication by talking, but by really using the sense of touch and doing something in the real world with a high performance central nervous system, you can say, right? So I think this is 100% the way to go. At the same time, having said that, I think we really still need to take that step, because if you wander around in automatica, then there is many things that are still on the motion level. But I think what you guys have in your mind is really democratization of physical skills, which means, and I know Stefan Schaal is also here, who has been one of the foremost AI persons in robotics that I know when I was a PhD student still, and he has done many of the fundamental work there. And I think we all agree that this is really one of the most fundamental things we need to do in robotics. To give our robots these aforementioned skills, they need to be interacting with the physical world, which means sense of touch, which means force control, compliance, and in particular safety around objects, the environment, and humans, obviously.
And actually,
maybe to add on, if you build on that, I think acceptance on a shop floor. You need to find a way how you maintain it, how to do diagnostic, and there will be not the IA expert, and there will be. So I think that's if you get this done, how you do an easy diagnostic, a robot is shipped somewhere in the Philippines on an island, and something happens. How can you make this robot run again, and with the people with local skills? And that's also something very important, beside even be more sophisticated. And I think that's what we can learn from OT, because there might be not a cloud connection, there might be not a remote diagnostic. You need to train the people, or the people need to be capable, which are there to make the machine or the plant run again.
I think that's right.
Looking at, and this is the last topic I want to talk about, looking at what you've talked about, for me the biggest challenge you'll have will be this transforming the mechanical engineering industry into a software industry. It's a completely different way of solving problems in doing engineering. How will you encourage the people who manage these shop floors, these engineering companies, to make this transformation? How can you?
Well, my dream is that somebody who can. Well, I tell you why was a PLC so successful? Because it was speaking in the language of an electrician. You didn't program. You basically did a wire diagram and then you programmed it. Yeah, that was why it was so successful. And the question now is, how can we make it as easy as possible for people which can do this, with a little upskilling. I wouldn't say it's for free, but at least a little upskilling that they can use it. And that must be our goal as industrial companies, to make those complex technology as easy as possible, but in an environment where you have people which are currently running machines, running industry. And that transformation is important. There are some good steps into that, but that's going to be crucial.
You know what is kind of funny? I'm just thinking about my president coming in 20 minutes or something, and I'm going to tell him, at TUM what we're doing right now is we want to build a new master's program that is designed to bring engineering and computer science together into a robotics and machine intelligence program. And I think what is the greatest argument that I just realized is to say, Siemens and Intrinsic were on a stage, and I was able to listen to that, and we need to do it today and not tomorrow, because we are still hesitant in that. So I really think that the skilling of not only the workers, but even the academics is really important. I mean, I remember when I was a student, I had to do CS and electrical engineering, full programs, to become an engineer and a computer scientist. And I'm still not sure which brain to activate every morning, right? The software person or the engineering person. And it's really important in robotics that we need to look at this traversal, discipline that is emerging here. And I think this is so fantastic that you guys are kind of, showing that German engineering, Siemens, and US, let's say AI software-driven business is coming together, and this is kind of what robotics is about, right? So not robotics today, but hopefully tomorrow. And I will take this away and push that through, so that, in maybe 1 year we're going to have an international masters that is going to integrate that, so that we can produce the best engineers. No, robotics. What do we call them, by the way? Roboticists? The best roboticists for the German and European market.
Maybe, but I think they'll almost be application engineers. I mean, maybe the thing to end on here is the hybrid integration of skills as us as human beings. That's what the ecosystem is. So our team, for example, it's not an accident that I'm a software platform person. Brian is a roboticist software platform. Stefan is a professor in the academic side of force feedback. Torsten is a controls expert. We have literally had to come together to have any chance of integrating this. And I'd actually say academically you're right. I don't think there's anyone there, right? So in fact, one of your colleagues, Daniel Ruckert, was my department of computing head at Imperial College.
Now he's at TUM, right?
And now he's at TUM.
We're very happy to have him.
But I think your point is right, is that there needs to be more hybrid education to meet this hybrid world shift that's actually going on right now. And actually, we should multi-skill folks. So the mechanical engineers can also be process engineers. They should be able to use our interface already, actually, because of the process engineering side. But I think as an ecosystem, we actually do need to work together to step things forward. And why? Because there's a bigger imperative right now in the world, which is technology and AI is fundamentally going to change the world in the next 5 years, not in the next 20. We have climate problems now. We have geopolitical problems now, and so we better solve some of these things together now, and not worry about staying proprietary in our, in our backward looking into how our business models used to work, because that's not going to help us moving forward.
So we are going to solve these problems, and next year or the year after, when you come back here, you'll see lots of the solutions from these people. But I also don't want to make empty promises. I did say that if there's anybody who's got a question, you can pose it here. If there is, put up your hand and I'll give you a microphone. Briefly say who you are and ask your question.
Arno Strutken, ex-vice president from robotics in AUB, now independent, working with startups. Where do you see the adoption coming to your platform from the, let's say, startups, new players? Or how do you see the adoption from the big players? Because today you didn't talk at all about Fanuc, ABB, Yaska, Bakuka, which are the number one players in robotics. I mean, Siemens is very, of course, good in PLCs, but is not the player in the robotics industry. Those players will protect because their differentiation is their motion control, all the application know-how they're built on not only, let's say, pick and place, but welding, painting, all the different applications you have that are really interacting with the controller of the robot. And also the mechanics, which is, 20, 30 years of mechatronics.
Yes.
And that is a close collaboration. So how do you plan to bring those players in? Either convince them, or do you see basically some startups coming up and adopting your platform, and that will change the whole industry?
It's a great question. I might have. You're probably not surprised because we're in an ecosystem. We are talking to those players too and working with them in different forms.
Can you keep the
They know the world is shifting. So I think just being a proprietary ROEM, much like other industries have broken in the past, is not the future. So they actually want to move up the solution stack as well, of value. And so the question here is, why would they do that? They would do that in the end. Where the end customers go is where they will go to. Now, we work a lot with end customers already who want to build different types of solutions. And when those big end customers say, actually, we want to use a platform that's more interoperable, the ROMs come too, actually, as well, because they want part of that value. Also, we're actually creating new markets, as you said. It's not just new ROMs, it's actually new markets. So if you move into SME and Greenfield and create applications that weren't even possible before, those old ROM players want to move into those new solutions too. And you can't do that without a certain amount, if I'm honest, AI skills that are coming in robotics, as much as integrating that to the OT world as well. So in the end customers will drive change, as most markets do.
Okay, we have time for one more question here in the second row.
Hi, Carsten Mittelmann from Eplan Software. I have a question regarding the role of China. If you want to make the solutions come into reality, you need scale and you need resources. Now, China currently has a very rich ecosystem of both hardware manufacturing, software engineering, etc. Where do you see the role of China in this change that's coming? Is China going to drive, or is it going to be in China for China strictly?
Well, do you want to start there? Because you're in China.
Well, we are very strong in China. So we see the China market is moving partly from being, let's see whether it works somewhere else. And if it's proven, then they're going to adapt it. We see China moving also into new innovations. And we've seen some industry where China, in the meanwhile, is leading. So they have been fast in creating something new. So I think, as I think the most population of robots are anyway in China, China need to be somehow part of the game. And but they need to find a role. I'm not sure how that looks like, but I think it will not work without China.
Then thank you very much for a very interesting discussion. Unfortunately, we have to break it here because, like Sammy said, the president of Bavaria is coming. Somebody's got to
President, we have a president.
Could you?
I think the minister is coming.
Thank you, Sammy. Thank you, Wendy. Thank you, Rainer. Thank you all for participating. Look forward to seeing you next time. Bye-bye.
Thanks, Ken.